Let's review some of the main ideas in this chapter, and maybe the most important idea is this: the first law of thermodynamics, which says that the change in energy, in thermal energy of the system, is equal to the work plus the heat. And you have to realize that this is nothing else but the conservation of energy. And it is important to understand these quantities here, work and heat. If the system is expanding, then the system is doing work, is losing energy, and the thermal energy decreases. If the system is being compressed, then the environment is doing work on the system, the environment is adding energy to the system, and the energy increases. If the system is being heat up, energy is being transferred to the system in the form of heat, and the thermal energy increases. And if the system is cooled down, then the energy is leaving the system, and the thermal energy decreases. It is important to understand that W and Q depend on the path that you use to go from one point to the other. But the sum W plus Q doesn't. This is the thermal energy. Okay? So this is an important idea that we need to understand. So the three main quantities in the first law is the thermal energy. This is the energy of the system. This is the energy coming from the motion of particles. In the case of an ideal gas, it's just the sum of the kinetic energy of each of all the particles. Work is energy transferred to the system by means of mechanical interaction, compressing or compressing the system or letting the system expand and push something. Heat, on the other hand, is energy transferred to the system by means of atomic collisions, atoms colliding with each other. There is one more important, well, we'll go through that in a little bit. So work, what is work? Work occurs when the system expand or compressed, and in this case we have an expansion, and the work is just the integral from the initial volume to the final volume of P dV, and this is the pressure on the gas, and the minus here is because we want the work done by the environment on the gas. And typically and the work is the area under the curve, this purple area here. Adiabatic processes are important processes. These are processes in which there's no heat, and they have a slope that are steeper than the isotherms, and they cross these temperatures, so they go from one temperature to the next. There is also the property that PV to the gamma is equal to a constant, where gamma is just Cp over Cv. In calorimetry, we have this nice relationship that says that the heat, the net heat occurring in an isolated system has to be equal to zero. So if I have a bunch of systems, one, two, three, and they are different temperatures, and there's going to be heat transfers between them until they all get to the same temperature, and the sum of those heats is equal to zero. The heat of transformation is the energy that you need to produce a phase change, and is equal to the mass times this quantity L, which is the heat of the energy that you need to transform 1 kilogram of the substance. The specific heat is the energy that you need to raise the temperature by 1 Kelvin, and the molar specific heat is the energy that you need to raise the temperature of 1 mole by 1 Kelvin. There are these relationships. Cv is the molar specific heat at constant volume, and Cp, which is equal to Cv plus R, is the molar specific heat at constant pressure. There are two ways of conduct energy. Well, there are two ways that have equations. There are three ways that we looked at. Uh, Conduction and radiation, the rate at which heat is transferred through conduction is given by this equation. The rate at which heat is transferred by radiation is given by this equation, and the ways in which we transfer heat are conduction, convection, radiation, and evaporation. There is also one more equation that is not mentioned in this summary, is that whenever for an ideal gas, whenever there is a change in energy, that change in energy is equal to the number of moles times the specific heat at constant volume times delta T, the change in temperature. And this is true no matter the process if there is a change in energy.